Example 3. Suppose that 1000 rands is deposited into a bank account. 1 month later, a further 1000 rands is deposited into the account, and then a further 1000 rand is deposited 1 month after this. If the interest rate is 6% per annum compounded monthly, how much will have been saved after 2 months? Now, in this example, instead of putting one principal amount into an account and then watch it grow, they keep depositing that same amount each and every month. So this causes the principal amount to grow, and then another principal amount is added, and then they both grow, and then another principal amount is added, and all three of them grow as the investment period continues. This is basically a compound interest question that continues. Our principal amount is 1000 rand and our interest rate is 6% per annum compounded monthly. Investment period is 2 months. So we need to draw a timeline to understand this clearly. So our timeline looks like this. At month 0, they opened the bank account and deposited 1000 rands. And then after 1 month, they deposit another 1000 rands. Then after the second month, they deposit another 1000 rands. So when we calculate this, we're going to have to look at how much the first 1000 rand will grow to the following month, and then we will add the second 1000 rands and then see how the total money in the bank account grows to the following month. So we have accumulated amount is equal to principal amount into 1 plus I to the power of n. Our principal amount is 1000 rands into 1 plus our interest rate as a decimal is 6% divided by 100. It gives us 0.06 divided by a compounding frequency is monthly. So it is 12 to the power of, now we are only compounding this 1000 rand into 1 month. So the power here is not 12 because we're not calculating how much this 1000 rand will grow for 12 months. We're only focusing on 1 month. So the power is 1. 1000 rands into 1 plus 0.06 divided by 12 to the power of 1. 1005 rands. So this is the amount of money that this person will be having after 1 month of investing. But then immediately after 1 month, he deposits 1000 rands into the account. So we add the amount that has accumulated for 1 month with that deposit, and we get 2005 rands. So this is the money that he will be having after 1 month, and we're still left with the second month, so we need to calculate 1 for the second month. And as we do that, this becomes our new principal amount. So we have accumulated amount is equal to principal amount into 1 plus I to the power of n. Our principal amount is 2005 rands into 1 plus interest rate is 6%, but 6% divided by 100 is 0.06 divided by compounding frequency is 12 because it is 6% per annum compounded monthly to the power of 1 because we're still focusing on 1 month. From month 1 to month 2, it is only 1 month. The answer that we get is divided by 12 to the power of 1. 2015 rands 0.25 cents. This is the amount of money that they will be having after 2 months before they deposit the last 1000 rands. So when they deposit this 1000 rands, it will be added to the available balance that will be reflecting in their account. So at the end of 2 months after depositing, they will be having 3015 rand 0.25 cents. So by doing that, we answered their question. They asked us how much money will they be having after 2 months, right? But then people don't normally invest money in a bank for 2 months. They do it for years, right? So if we were to calculate how much money they will be having after, let's say, 6 years, it is compounded monthly, we were going to do many compound interest calculations for each and every month for 6 years. So there's got to be a way to do it using one formula and doing it once. So this is where annuities come in. An annuity is a series of equal investments. As we have seen in this example, they keep on investing 1000 rands each month, or loan payments at regular intervals. After 1 month, they deposit 1000 rands. After 1 month, they deposit 1000 rands. So the intervals are regular. It is always 1 month. Regular interest, subject to an interest rate over a period of time. The interest rate for the entire 2 months was 6% per annum compounded monthly. So an annuity again is a series of equal payments or loan payments at regular intervals subject to an interest rate over a period of time. Now, what we just did here is we calculated how much money this person will be having in the future, which is 2 months in the future. So in the present, when he deposited his first 1000 rands into the account, and then we want to see how much money he will be having in 2 months, and we found that they were going to have 3015 rands 025 cents. So this is called a future value annuity, and its formula looks like this. The future amount is equal to x into small bracket 1 plus interest rate as a decimal close to the power of n. Now n here is different, minus 1 close bracket all divided by interest rate as a decimal. X represents equal payments made per period. So in our example, we had 1000 rands as x. I represents the interest rate as a decimal like we usually do, and n here represents number of payments made. So let's use this formula, which will help us skip all of this tedious calculation and only calculate this once. So the formula is the future value that this person will be having is equal to x equal payments made per period into 1 plus I to the power of n minus 1 close all divided by interest rate as a decimal. Now our regular payment 1000 rands, right? 1 plus our interest rate as a decimal, it's 6% divided by 100. It gives us 0.06 divided by our compounding frequency is monthly, right? So it is 12 close to the power of n. Now n, like I said, represents number of payments made. So when we check in our timeline or number line, this person made a total of 1, 2, 3 payments. So n is equal to 3 minus 1 all divided by interest rate as a decimal 0.06 divided by compounding frequency. The answer that we get should be the same as this one. This is a big formula and it involves a lot of value, so we need to be careful when you put it into a calculator. Say fraction 1000 rands into 3015 rands 0.25 cents. This is the amount of money that they will be having at the end of their 2-month investment. So using this formula, we skipped all the calculations that we did. We did 2 actually when we were using the compound interest formula. So this is the future value annuity calculation. Let's do another example. Example 4. Suppose that 1500 rands is invested every month starting immediately, meaning at T0 or immediately after they open the account, they deposit 1500 rands for a period of 12 months. Interest is 18% per annum compounded monthly. The future value of this investment after 12 months will be the sum of all payments together with the interest earned. We are supposed to calculate the future value of this investment. Our future value is equal to equal payments into 1 plus interest rate to the power of number of payments minus 1 close all divided by interest rate. Equal payments, which is x, is equal to 1,500 rands, right? This is the money that they will be depositing every month into this account. The interest rate is 18% per annum compounded monthly. Now usually when the interest rate is compounded monthly, the compounding frequency dictates how often they will put the money into the account. So if it was compounded quarterly, then they were going to deposit 1,500 rands each and every quarter, which is every time after 3 months. Now we need to be careful here. They said the 1,500 rand is invested every month starting immediately. So our N here, which is the number of payments made, is added by 1. So we say N plus 1, because remember, N here is not equal to the investment period, right? And N is not equal to the compounding frequency, but N is equal to number of payments made. So our compounding frequency can be monthly, right? And you would expect that N will be 12 months, but then N is number of payments made. So interest rate can be a certain percentage compounded monthly, but then the person who's making these regular payments won't necessarily make 12 payments. You get what I'm saying? In this case, the investment period is 12 months. But then immediately when they opened the account, they deposited their first 1,500 rands. So number of payments here is actually 13. See, you need to be careful here. So let's calculate it. We have 1,500 rands as the amount they pay regularly to this account into 1 plus interest rate is 18%. But we divide it by 100, we get 0.18 divided by compounding frequency is 12, because they said monthly, to the power of 13, or I was going to say N plus 1, and our N is 12 plus 1, which gives us 13. 13 minus 1 close all divided by interest rate as a decimal. 0.18 divided by 12. Now again, this formula is big and it has a lot of value, so we need to be careful when we put it into our calculator. Fraction 1,500 rand into again minus 1 to the power of 13 all divided by 0.18 divided by 12. 21,355 rand 24 cents. Now this is the amount of money that they will be having after 12 months of investing in this account. So this is the introduction to future value annuity. Thank you for watching. See you on the next one. Mr. Klaus signing out.
It's easy to see when you look at me. If you look closely, Mystic don't back down. Subscribe to this channel if you haven't already, so that you can get that A in mathematics.
Leave a comment down below if you have a question. Mystic will make sure you get the answer.
Leave a like and share this video with your friends, so that we can all be good. Thank you for watching.